Hello. Now I shall discuss about how to parallelize the sorting. That if we have some set of data, that how to sort with some fundamental with the help of some fundamental operations. That suppose we have the 100 values, we have the 1000 values, we have the 100 million values. That how those values are to be distributed onto the different processes. So the fundamental questions that we have to consider is that whether we should distribute the elements or not distribute the elements, whether it is being required or not. If that suppose that we have a uh, following architecture in which is a three-dimensional mesh in which there are 27 nodes are there. Now suppose we want to um, we want to now suppose that we have some 27 values, so we can easily be able to assign one element to each of the node of this particular mesh. So we can be easily be so there's no need to there's no need to consider a lot with that how we have to distribute the elements. Or suppose that we have this three-dimensional mesh type of architecture, and the number of the elements that are to be sorted are just 20. So we can easily be able to assign those values onto the nodes of this mesh. But if we will assign these elements onto the nodes of the mesh, um, then onto some other mesh, then it may be problematic. Because suppose that if we want to sort the 20 elements onto onto a two-dimensional mesh having the 16 nodes, then it will not be easy task. So similarly, if we have a four-dimensional mesh in which there are 16 nodes are there, if we want to sort the values, suppose there are 100,000. So for the 100,000 values, the 16 elements will not be enough, because I cannot be able to assign a single element to each of the node of this hypercube. I can only be able to assign the values by dividing 100,000 by 16, and then whatever the quotient is there, those values are to be assigned towards each of the nodes. So in this way, we have to consider that whether we want to divide the elements or not. And if we cannot be able to divide, then what should be the methodology to divide the values. So with respect to these choices for the parallel algorithm, we have the following choices. Either either we can be able to assign all elements on one process. There are some scenarios are there in which we can be able to assign all elements on one process. But one thing is to be noted, that this method is not useful, because if we will assign all elements on a single process and not onto the multiple processes, then I can easily be able to say that there is no parallelization, or I should say that the parallelism is lost, because the multiple processes are not running simultaneously, and that is not speeding up the task. Let us understand with some scenarios. The first scenario is that if we are working on an algorithm that is to perform only sorting. Suppose that the number of the elements are just 100,000, and it is to perform not any other task but only to sort the values. Then uh, then the, and we have an architecture which is having the 100,000 nodes also. So uh, so uh, so rather than distributing all of these values onto each of the nodes, I am I I have allocated all the elements onto a single process. It is certainly possible, but again, this whole method is reduced to the sequential algorithm, and we want to avoid it. Now, the second scenario is that if suppose that we want to break a secret code, we want to decrypt a secret code which which is being which has been captured from some enemy. Now, if now in order now I have a particular process which can be able to decipher decipher that secret code by first of all converting the secret code into the some ascending order manner, and then it will decrypt it. So in that case, the sorting is an intermediate step of the algorithm. So here in this case, it is certainly possible that we can be able to allocate all elements on one process, because if we have if we have not uh, a pool in which from which we can be able to allocate as many processes as the number of the elements, then because the rest of the processes are busy, so in that case we can be able to assign all elements onto single process, because if we don't want to wait, then this is the only scenario that can be followed. And in that case certainly this method is not useful, because again the parallelism is lost. So the third scenario is that if we are working on the algorithm where the sorting is an intermediate step, then we should allocate those elements onto the multiple processes. Either I can be able to assign if the number of the values are limited, as well as the number of the processes are limited, and we can be able to perform one-to-one mapping with respect to the elements and the processes. Then then a single element can be able to run on a single process. But if we have more number of the elements are there, and less number of the processes are there, then we have to divide the number of the elements by the number of the processes, and then those values are to be assigned towards the each process. So in the scenario 3, if we are working on an algorithm where sorting is an intermediate step, then we should allocate the multiple elements or some set of elements onto the different processes, and it will enhance the speed. So in this way we can be able to understand that one of the scenario is that either I can be able to allocate all elements onto a single process, but the parallelism is lost. The other thing is that I can be able to assign either multiple elements on a single process or a single element onto the single process. Here it should be noted that the multiple elements means multiple elements uh, may mean that either I can be able to assign the same number of the elements onto each of the process, or unequal number of the elements are to be assigned onto the multiple processes. Now there are different concepts. For the sorting. Let us now in order to understand that, let us assume that the input and the output lists are distributed among all of the processes. That we have to consider that all of the elements are distributed. Now, how to perform the sorting? Now before discussing that, we should understand that suppose that there are two different processes, process Pi and the process Pj. Then when these two processes will take part into the sorting, then the values will be exchanged. Um, then the then the values stored at these processes will be sorted with respect to their subscripts. If the value of the subscript I is lesser than the value of the subscript at the j, then the smaller values will be stored at the process pi, while the larger value will be saved at the process pj. It can be understood by the following example. Suppose that there are two different processes, um, process P20 and process P30, where we can be able to observe that the subscript 20 is less than the subscript 30. So in that case, when these two processes will take part into the sorting, then the smaller value will be retained by the process P20, while the larger value will be retained by the process P30, while the rest of the values will be discarded. Same thing. So if both of the processes are having only a single element, then the smaller value will be stored at this node, while the larger value will be stored at this node. And if both of the both of the processes are having the multiple values, are having the multiple values, then the smaller set of values will be saved at the process P20, while the larger values will be saved at the process P30 after the sorting. Now, how to perform the comparison? Now, one thing that is to be considered, that how we should perform the comparison. Now, how to perform the comparison? It is to be decided with respect to the distribution of the elements. With respect to the distribution of the elements on the processes, either one element per process method is to be employed, or the multiple elements per process are to be employed. That I shall explain into the next video.